Hello, dear students. Welcome back to Carbon. Yeah, let's have a moment of chemistry with my YouTube channel, Carbon. Yeah, so again, we are doing textbook exercises from your first chapter, and today we are going to study about limiting reagent and molarity, and we are going to do 2-3 questions from your textbook on regarding these two concepts, limiting reagent and molarity. Let's start. Okay. Yeah. So first question, calculate the amount of carbon dioxide that could be produced, and three sub parts are there for this particular question. 1 mole of carbon is burned in air, 1 mole of carbon is burned in 16 gram of dioxygen, and then third one, 2 moles of carbon. So here is the problems related to moles, grams. Yeah, the main concept here is limiting reagent. Okay, what is limiting reagent? Yes, before going to limiting reagent, let's write the equation. So in this chapter, when you are getting any question like in terms of moles, weights, and you need to find out the amount, first of all, you just write the equation, the balanced chemical equation, which is very, very important. Okay, so you need to write it. Carbon react with dioxygen O2, we will get CO2. This is the first equation you need to write. Okay, so this is the first thing you should do when you get a question to find out the amount. Okay, so it may be related to molality, it may be related to limiting reagent, whatever it is, you just write the equation. Then, as a second step, you need to write the number of moles present in reactant. Here, only one carbon, right? So, 1 mole. Here again, 1 mole. And the product is also 1 mole. There is no another coefficients are present in the left side of elements. So, 1 mole is there. Okay, then here we need the amounts, then just we write the equation, masses of the particular element. Carbon weighs 12 gram. Okay, so by doing lots of question, you may be by heart with the amount or the weights of elements. And here two oxygen molecules are there. For one oxygen it weighs 16 gram, and for two molecules it weighs 32 gram. Yeah. Then carbon dioxide, yeah, you remember law of conservation of mass. Reactant, the weights of reactant always equal to weight of product, right? So 12 plus 32, it is 44 gram. Or you can count the molar mass of carbon dioxide. Then also we will get 44 gram. Okay, so this is the first step of the particular problem. So then let's start. Yeah, it's about limiting reagent. What is limiting reagent? So you can note it from the definition I have given. A limiting reagent is the reactant limiting reagent, which is the reactant present in a reaction, okay, which is in lesser amount and which determines the extent of reaction. Get it? Is it now, is it confusing? Limiting reagent means, so in case of carbon and oxygen, these are two reactants present in this particular reaction, right? And one of the reactant is limiting. Okay, so by doing this sub question, you will get a clarity regarding limiting reagent, and we are getting CO2. Okay, so based on this limiting reagent or based on the reactant present in lesser amount, limiting reagent is this reactant present in lesser amount, which determines the extent of reaction. Okay, so let's do the sub question. First one, 1 mole of carbon react with 1 mole of carbon is burned in air. Okay, burned in air means excess oxygen burned in air. Here it's 12 gram, here it is 32 gram, and here it is 44 gram, and everything is 1 mole. Okay, so we need amount of carbon dioxide produced, amount of carbon dioxide. In this particular case, amount of carbon dioxide was 12 grams, which is 1 mole of carbon, and in burned in air, which there is no specification regarding the weight of oxygen in this particular part. And 12 gram, that is 1 mole of carbon gives 44 gram carbon dioxide. Okay, so the first part is there in this question itself. 12 gram produces 44 gram of carbon dioxide. Get it? So which is the limiting reagent here? Carbon is the limiting reagent in this part only, because carbon is in lesser amount, and when all the 12 gram of carbon has been consumed, the reaction stopped. Okay, and this 12 gram of carbon determines the rate of reaction. So this is limiting reagent. So in this part, carbon is the limiting reagent here. Carbon is the limiting reagent here. Easy? Yeah. Next part, 1 mole of carbon react with 16 gram of oxygen. 16 gram of oxygen. Then what will be the carbon dioxide produced? Okay, 1 mole of carbon with 16 gram of oxygen. Get it? So here 32 gram of oxygen gives how many gram of carbon dioxide? 32 gram gives 44. So we need this comparison. 44 gram of carbon dioxide. Yeah, then it's easy, right? 16 gram of oxygen produces how many gram? 22, exact half, 22 gram of carbon dioxide. So here who determines the rate of reaction? Here oxygen determines the rate of reaction, which means that oxygen is the limiting reagent here. Oxygen is the limiting reagent here. Okay, it's okay. Any doubt? Here 1 mole of carbon means 12 gram of carbon react with 16 gram, means the amount of oxygen has been reduced. Okay, so here oxygen determines the rate of reaction. So oxygen is when the 16 gram of oxygen consumed, we will get 22 gram of carbon dioxide only. Okay, because oxygen determines the rate of reaction here. Yeah. Then third part, let's do third part. Third part, 2 moles of carbon, 2 moles of carbon burned in again 16 gram of oxygen. 2 moles of carbon. Okay, so here it's about the limiting. 16 gram of oxygen is the limiting reagent here. So whatever happens in this left side, or whatever the amount of carbon we have taken, there is no change in the product. 16 gram of oxygen always produces 22 gram of carbon dioxide only, because oxygen is limiting reagent. Oxygen amount of oxygen has been reduced, which is in lesser amount. So 2 moles of carbon means 24 gram of carbon with 16 gram of oxygen. There is no change in the amount of product, because oxygen is the limiting reagent here. 16 gram of oxygen in this particular reaction always produces 22 gram of carbon dioxide. Clear? It's about the limiting reagent. Yeah, next question. Another one, A plus B2 gives AB2. So you just identify limiting reagent in these 5 cases. Okay, so I hope now you have an idea about the concept of limiting reagent. So let's do 300A plus 200B. So our reaction is like A plus B2 gives AB2. So here we are taking 300 molecules of A, molecules or atoms, then 200 molecules of B. So here the mole, 1 mole, which means 1 mole of A react with 1 mole of B2 to give 1 mole of AB2. So what is the story of 300 atoms of A with 200 molecules of B? Which means that this 200B react with 200 molecules of A, right? 200 molecules of B react with 200 molecules of A and we will get the product. Then what is the leftover thing there? What is the leftover thing there? Yes, from this 300 molecules of A, 100 molecules of A is excess, which is excess. 100. So A is in excess. So who is limiting reagent here? So our question just identify limiting reagent. So limiting reagent in this first part is B. Is it easy? I'll repeat again. 300 atoms of A plus 200 atoms of B. These 200 atoms of B determines the rate of reaction. 200 atoms of B react with 200 atoms of A only because the ratio is 1 mole ratio. React with 100 A. 200A, then 100 molecules or atoms of A is in excess amount, so B is limiting reagent here. Likewise, we just find out here also 2 moles of A react with 3 moles of B. 2 moles of A with 3 moles of B. Here also 2 mole A react with 2 mole B, right? 1 mole B is excess. 1 mole B is in excess amount. So who is limiting reagent? Limiting reagent LR is A. Limiting reagent is A. Okay. Then third one, 100 atoms of A with or 100 atoms of B. The 1 is to 1 ratio. There is no limiting reagent. The equation is always in stoichiometric. This mixture is stoichiometric, so there is no limiting reagent. No one can determine the rate. Both are equally. The mixture is equally stoichiometric in a way. Okay. Then fourth one, 5 mole A react with 2.5 mole B. So which is a lesser amount, 2.5. 2.5 mole B react with 2.5 mole of A. So A is excess, B is the limiting reagent. Likewise, we just do the fifth one also. Yeah. So we are moving to our final question, which has the application of molarity. So we can write the equation. So you just remember what I said, like whatever the question, if it's related to molarity or you need to find the amount, we just write the balanced chemical equation. CaCO3 plus 2HCl, which is balanced, CaCl2 plus CO2 plus H2O. Okay, and then you just go deep dive into the question and you just write the values, the weight or mole. Here it is 1 mole, here it is 2 mole, here 1 1 1. So you just don't go to the product side because what mass of calcium carbonate required to react completely with 25 ml of HCl. Okay, so the question comparison lies in the left reactant part. So you just don't go to product side. So 1 mole and 2 mole. And another uh, complication lies here, 25. So here asking about the mass and the given data is like 25 ml 0.75 m. What does it mean by this m? Which is molarity, not molality. Okay, molarity is capital M, molality is small letter m. Okay, yes, we need the equation of molarity. Molarity, yeah, just write the masses also. This is 100 gram. When you count the whole atomic masses of calcium, carbon and oxygen, you will get 100 gram. And for exam they will give the value of either it is individual value or they will give the whole atomic mass. Then 2 HCl, hydrogen 1, chlorine 35.5, then 36.5, and 2 into 36.5 we will get 73 gram. Yeah, molarity means number of moles of solute. Solute means when we are preparing HCl solution, HCl molecules are the solute. Moles of solute, we can represent it in N. Moles of solute divided by volume of solution, which is in liter. Volume of solution always be in liter. Okay. So the given data is molarity is given 0.75 is given, moles we don't know, and oleum 25. It is in ml, we need it in liter, so we just need to divide it with 1000. Then we will get n equal to 0.75 into 0.025. Yeah. Okay, then we will get moles like gm by gmm. What does it mean? You studied in 10th standard. It's the value of number of moles given mass divided by gram molecular mass. Yeah, gram molecular mass. Then we will get 0.025 into 0.75. Yeah. So the mass, given mass we don't know, given mass divided by molecular mass is 36.5. 0.025 into 0.75. So the mass of HCl, this much is HCl is 0.684 gram we will get. Okay, so doing this part, this molarity part, if the question for 4 mark, you will get 2 marks. Half of the marks you will already get when you just by heart the equation and just put the values in it, and then you will get the mass of HCl. Then the question, we just reread the question again. What mass of calcium carbonate is required to react completely with 25 ml of 0.75 molar? Okay, now we don't want to say 25 ml of zero point 0.7. Now we can say 0.684 gram of HCl. Yeah, so I'll write the equation again. CaCO3 plus 2HCl. Here, 100 gram of calcium carbonate react with 73 gram of HCl. Get it? 100 gram of calcium carbonate needs 73 gram of HCl. Then, what mass of calcium carbonate is needed for this value? So, for 1 gram of HCl, how much gram of calcium carbonate needed? 1 gram of HCl, 100 divided by 73 gram of calcium carbonate we needed for 1 gram. So for 0.68 gram of HCl, we need 100 by 73 into 0.684. Any doubts here? I'll repeat. Here for 100 gram or 73 gram of HCl need 100 gram. For 1 gram of HCl need 100 divided by 73 gram of calcium carbonate. So for this much value of HCl, you just multiply it with, then we will get 0.937 gram of calcium carbonate. Yes, students, so we studied limiting reagent here and the problems related to molarity. So do more practice questions and I hope it's clear. Okay, thank you so much. Bye bye.